Hi and welcome to another Unity tutorial. In this tutorial I want to show you how you can move a character around on a terrain by clicking on the terrain and have the character turn towards that point and then move to it. This is a terrain, but this will also work on anything that has a collider on it for clicking and setting up the position. A little later I'll also show you how to add this projection that sits around the character, and we'll use it to define the limits to which the character can move within for each turn. To begin, you're going to need a terrain, and I've just created a really quick terrain here, and you'll also need a character, and in this case I've got the tank from the Unity Tanks tutorial that you can find in the asset store. If you want to follow along and you don't have this tank, you can also use a cube. It's going to work the same way. On your character, in this case the tank, you want to add a rigid body and also a box collider. So select the tank object and go add component, and you want to look for rigid body and also the box collider. When you add the box collider onto your object, you might need to resize it. If I just zoom in here, you'll be able to see the green lines are the box collider. Now, if you add a box collider onto this particular tank, it will be smaller than the tank and you'll need to resize it. To do that easily, you can click on this button over in the inspector next to Edit Collider, and it'll give you some little dots on the side of that collider. And if you select those dots, you can modify the collider in real time in the scene view. So you want to set that collider up around your object as neatly as you possibly can. Also, make sure that the collider is above the terrain or the ground plane that you're using. Otherwise, when you press play, it might fall straight through. Next, create a new C# file and call it tank controller. In this case, I've already got one, but it's in the project. Go create C# and call it tank controller. When we open that code up, you'll see that it's pretty much empty. The first thing we have to register is the mouse clicking in the window, and to do that we'll put the code inside of the update function, and it's going to look like this. So we're saying if the left mouse button is being held down, that's the get mouse button function, and it's 0 for the left mouse button, and it would be 1 if you wanted to use the right mouse button. So this will register a mouse click. And then when it does, we want to run something called set target position. And this will be our own method that we write to grab hold of the position where the mouse is clicking on the terrain, and then using that to set a target location for the tank. The set target position function we'll put down here, and it will look like this. Now what this function is doing is it's casting a ray into the environment from the position of the mouse. So input.mousePosition will give us the position of the mouse on the screen, and then this camera.main screen point to ray will turn the mouse position into a ray heading off into our environment. Conceptually, what we're doing is we're taking the mouse position and we're pushing a line directly out from it, which is perpendicular to the screen, and looking for where that line hits the environment. That line is our ray, so it's a vector from the screen into the environment, and where it hits the collider of the terrain, that's the hit point. Back in our code, the ray is declared here, and the hit point is also declared here, but it isn't given a value. What gives it its value is this physics.raycast, which sends the ray into the environment and then brings back our hit position. Now that ray that we're sending into the environment is set to be a certain distance, because of course you could send a ray out into the environment and it could go on infinitely, and you don't want it to go that far. In this case I've set it to 1,000. If you're doing this and you don't seem to be hitting anything, try increasing this value here as well to make sure that you have extended your ray long enough into the environment to hit something. Now, just before I test this also, I've got the target position that I'm setting with the hit.point value that we're getting back from the terrain hit. And that's because I'm going to use this target position a little later. This target position is a vector 3. So at the top of our program, we want to declare that as a vector 3 target position, like that. And then just save that code. Let's go back into Unity. Make sure that you attach your tank controller code to your tank or your cube, whatever you're using, and check in the inspector that it's actually attached down here. Right, so now when we run this, we can click on the environment in the game view, and you'll see that wherever you click, the tank now turns to face in that direction. And I can also hold the mouse down and it will do that as well. Now that's because, back in this code, we're using the this.transform.lookAt function. The lookAt function will turn an object so that its z-axis is facing the position that you give it to face. So as long as the forward direction of your model, if we find the tank in the scene, is along the forward direction, which is your z-axis, the blue one here, you'll be right. So your model will be facing in the right direction. Now we don't want the tank to be snapping around looking at each click position instantaneously. You'll want the tank to turn on the spot and appear to be turning. So we're not going to use this look at here, though you might want to use it in other situations. I'm just going to comment that out for now. What we need to do is to calculate the angle towards the new position, or the hit point, I should say. Now to do that, I'm just going to add in some code below the calculation for the hit point. And that is a look at target vector. And this will be the vector which is, this will be the vector pointing in the direction of the ray. So essentially it is the same as the ray, except I'm giving it the same Y value as the tank itself. This will keep the tank turning on the flat. So if you've got an object that needs to move along the ground, you don't want it to end up looking up in the air by complete accident, then you want to turn it around its y-axis, which is its up axis, and you only want to turn it in the X and the Z direction, so left and right, essentially. So by finding only the left and right differences, then we've got a position that will rotate the tank. So if we just go back to Unity for a second, just show you here. So this is our tank. Let's say that I click up on top of this mountain over here. If we were to look at that mountain from where the tank is, the tank would turn, and let's see if I can just do this for you. In an instant, it would turn like that, and it would be looking up at that position, which is quite an unnatural position for the tank. Now, because we've got the physics on it, it tends to just drop back down for us. Instead, what we want to do by keeping that Y value the same as the tank is that if the tank's like facing that direction and I click up on the mountain here, it will calculate the rotation that we need to do like that. So directly around its up axis, where it's going to take this point and project it down so that it's at the same height as the tank. And that will stop anything from sort of looking up in the air or rotating when you click on a mountain. This would be a problem if you have an animated character who's sort of humanoid and you want him to run up a hill. It could also rotate your character, unfortunately, so that it's not standing upright on the ground. So this is how we remove that, by removing any problem with the Y axis. All right, so that's our look at target. And then the next thing we're calculating is the rotation that the player has to take. So this is the tank's rotation that has to occur in order to look at the target that we're calculating here. So this look rotation works out the angle you need to turn to be looking at that particular target. Now, this look at target is a vector 3 that we need to define up the top, and this player rot is a quaternion, which we're also going to define up the top. So let's go up here and add in our vector 3 and our quaternion, which is our structure that holds the rotation. Okay, so that's in there. Right, now that we've done this, we can write a function called move, which will move the tank and perform the turning. Back in the code, just below the set target, I'll create a new function called move. And what move looks like is it's taking the rotation of the tank and performing a slurp for it. And a slurp allows you to transition smoothly between one rotation and the other. So this is the rotation that the tank's currently facing, and this is the rotation, the player rotation we calculated up here, where we want it to be facing. And so we'll get a smooth movement between these using a speed, and in this case it's rot speed, which we need to define, rotation speed, multiplied by our time.delta time to smooth it off. So up the top of our program, we will now define rot speed, which will be a float, and I'm going to set that to 5. You can modify this if you want the tank to turn quicker. And now we can run our move function, which I'll just put inside the update. So the update's going to go if mouse button's down, set a new target, but we'll always be running our move function to turn the tank around. So let's save that and we'll go back to Unity and try it out. So if I press play, you can see now that when I click, the tank slurps to the position rather than snapping. The next step is to get the tank moving. So let's go back to our code and we'll make the tank move in the move function, because that's what it's for. So we're going to rotate towards it, and then after that we'll add in another line which is doing a move. So the move towards function in this case is taking our position that the tank is in and our target position that we calculated earlier, which was up here, and it's the hit position on the terrain, and we're applying that to the position of the tank. So it's going to push the tank along towards the target position at a speed, which is defined here. So we need to create this variable speed at the top, and I'll put that with our rotation speed. So it's also going to be a float speed, and let's set that to 10. And again, you can play around with these values. So I'll just save that, go back into Unity and press play. What we can see is the tank immediately slides off the map. What it's doing is moving towards our target position, which has not been set yet because we haven't clicked. If you click in the environment, the tank will eventually come back from wherever it's gone to. Let's just start again. We'll let it slide away and then click, and then it will go to the new position. The other thing that you can see is that when it gets to that new position, it's jittering, and that's because the move function is running every update. And we don't want it to run every update, and we also don't want it to run right at the beginning. So let's add a little bit of logic in there to say if we have something to move towards it, and if you're already at the location that you need to be at, then stop moving. So the first thing we'll add at the top, bool moving, and we'll set it to false initially because we're not moving anywhere when the code starts to run. Next, inside the update, around the move, we'll put if moving, then run the move function. So it's not until this moving becomes true that this here will run. Now when it becomes true, will happen down in the set target position after we've created our hit point. And so let's put moving equals true into here. So that'll set it to true, which will make the move function up in the update run. But we also want to stop moving when we reach our destination, and that part of the code will go inside the move. So just down here, let's add that code in. And that says if our transform dot position, so the position of our tank, is equal to the target position, then we can stop moving. If you don't want to be this accurate, then you could add within a particular range of your target position, because sometimes depending on how you're moving your object around, it might never get to an exact position, and therefore you might want a range in there instead. In this case, we're saying it is exactly on that spot, because with the slurp and the move towards, we should manage to get it at the right location. So let's save this, and I'll just go back into Unity and run. And immediately when we press play, you can see the tank's not going anywhere because moving is currently set to false. So if I want to move over here, I can click, the tank will turn around and head over in that direction. You can also see that the jitteriness has stopped because that move function isn't trying to move the tank when it's on its destination. So it's not even running, it'll be set to false. In this particular case, because of the way I've got this physics set up, if I try and go up this hill, it's more than likely that my tank might decide to roll back and down, and it is, as you can see there, because it's stopped and it's not stuck on that terrain, because the physics is still going to influence that tank. And, you know, you could restrict the physics on there so that the tank cannot roll around in certain axes, and you do that by selecting the tank and going to the rigid body and having a look at the constraints. If you only want the tank ever to be able to rotate around its up axis, then you can freeze the rotation on the Z and the X, and that will stop it from tumbling around unexpectedly. And I'll leave this tutorial here, so you now have a nice tank that moves around to the click location, and it moves smoothly and it turns smoothly as well. In the next video I'm going to make, I'll show you how to project a target location around the tank onto the terrain, and then to restrict the movement of the tank within that range. So for example, if you're making a turn-based game, like a strategy game, and you only want units to be able to walk so far or move so far each turn, then I'll show you how that is possible. Thanks for watching, and as always, if you'd like to support the development of more tutorials, and you'd also like to request tutorials, then come along and join up on the Patreon website. All Patreons who subscribe will get access to my Udemy courses, and they also get access to all of the project files that I put up on YouTube.